Hello, welcome to another AQA A-level physics question on circular motion. If you want to try to answer the question yourself, pause the video now. If you got the answer D, well done. So a ball of mass 0.3 kilograms is attached to a string and it's moving in a circle of radius 0.6 meters at a constant speed of 5 meters per second. Which line A to D in the table gives the correct value for the minimum and the maximum tension in the string? Right, okay, so the minimum and maximum tensions are going to occur at the top and the bottom of this ball's orbit around this central point. So let's first of all have a think about the forces that are acting on the ball. There is a tension that is always acting inwards. We'll give that the letter capital T. That's the thing we're trying to find. But there's also the weight of the ball, which is acting downwards. So the weight of the ball, mg, is always acting downwards. Now, in order for this ball to move in a circle, there has to be a centripetal force acting on it. And that centripetal force is going to be the sum of these forces, but we must remember to see whether they are going to be added together, as they are at the top, because they're both in the same direction, or there's going to be the difference between the tension and the weight, as in at the bottom, because they're acting in different directions. So we can say that the centripetal force, which is always acting, is going to be mv squared over r. Now, at the top, that centripetal force is going to be equal to the tension plus the weight. Whereas at the bottom, the centripetal force is going to be equal to the tension minus the weight, because that resultant force, which is supplying the centripetal force, the weight and the tension are in opposite directions. So let's just carry on here. At the top, we can now rewrite this to say that the tension is going to be equal to the centripetal force minus the weight. And at the bottom, the tension is going to be equal to the centripetal force plus the weight. So if I find the centripetal force and I find the weight, I can find the tension, which will be a minimum at the top and a maximum at the bottom. So let's do that. Let's find the centripetal force. So the mass is 0.3 kilograms. The velocity is 5 meters per second, and the radius is 0.6 meters. If I put all those things into my calculator, I get an answer of 12.5 newtons. Now I can find the weight, which is the mass times the gravitational field strength. The mass is 0.3 kilograms, gravitational field strength 9.81 meters per second squared. We get an overall weight of 2.94 newtons. So at the top, the tension is 12.5 newtons minus the weight, which is equal to 9.6 newtons. And at the bottom, the tension is going to be the centripetal force, which is 12.5 newtons, plus the weight, plus the weight, which is equal to 15 newtons. 9.6 and 15 newtons, answer D. If that was useful, subscribe, like and share, and watch more of them in the series. Thank you for watching.